Thank you for joining today this global webinar. My name is Caroline Maitre and I will be your host for this event. I would like to thank you all for joining. Today's topic, we will be looking at modular plant design, more variation, lower complexity. I am delighted to welcome as our speakers today, Mr. Chad Jackson and Mr. Michael Mooney. I will give a very brief bio of the speakers and we will be ready to start. So Chad has a Bachelor of Science in Mechanical Engineering from the University of Kentucky. As the principal analyst of Lifecycle Insights, he has published over 100 publications, ebooks, and white papers, and also presentations, live events, and webinars. Lastly, he has surveyed over 1,000 engineering organizations as part of his research studies. Michael has been using 3D CAD since 1988, with over 20 years of industry experience in piping and process design, FEA, CFD, mod flow, electrical, and PNID schematics. For 19 years, Michael has been teaching CAD as well as simulation, technical publication, CAM, and 3D printing in large and small engineering companies.
Great. Thank you. I appreciate the invitation to allow me to join and talk about this topic. This is a really interesting one. Designing and constructing plants, processing plants in particular, it's an old school trade. We've been doing it for a long, long time. In the past few years, there's been this, I guess I would say, an innovative new approach to use modularity in platforms, which typically are associated with things like cars and similar types of things, to provide more variability and increased reuse simultaneously. So it's been a fascinating trend. So in terms of what I'm going to cover on this webinar, here's my agenda. First, I want to talk about trends that are kind of driving plant design complexity. And that's kind of motivating or pressuring a lot of organizations to move towards modularity as a solution to that issue. Then we're going to talk about modular design from a construction perspective, which is very different from modular design from an engineering perspective. And by the way, when I talk about it in the context of engineering, I'm also talking about response requests for quotes or bidding, the bidding process. A lot of times, if you're bidding on one of these projects, you have to do some design work to actually show that that you are capable and that you can actually deliver what's being requested. Then we're going to go into some of the specifics of this type of initiative. One is the alignment between functions and modules. We're going to talk more about that. We're also going to talk about interface management. And then we're going to dive into different technology enablers. There isn't actually one single solution that is a fit here. There's a number of them. Right, so it takes an ecosystem of these capabilities to be successful. So, with that said, let's dive into it. First off, increasing complexity in plant design. Let's talk about that. So, first off, there is more demand for custom equipment in these processing plants, and that's mainly driven because the complexity of the processes, the manufacturing processes that are being done in these plants are getting more complex. They're getting more refined. So naturally, you're going to have a change in all the equipment that needs to support that manufacturing process. So that is making it more complex. These projects are also getting larger and more complicated. So with larger projects, there obviously is going to be a lot more work, and that's happening simultaneously with the increase in custom equipment that we're seeing there. Furthermore, there's more regulations that are governing how these plants need to operate, but just as importantly, how they're being constructed. And that varies. Sometimes it's state to state. If we're talking about the United States, if we're talking about internationally, there's a lot of variation from, regional regulations and even within specific countries. So that is making things more complex as well. And all of this affects the request for quote, the design, and the construction processes. So let's move on and talk about this from a construction perspective. Now, traditionally, what you see is you design the processing plant. You then go out to a site and you start building it. And the issues that a lot of people are running into is that because of this increased complexity that we've already talked about, and due to the fact that there's a lot of variation at a construction site, right? There's a lot of surprises, right? There's things aren't exactly where you expected them to be. Maybe you have an interference where some ducting is where piping was supposed to go through. There's a lot of variation that you have on the site, and then, of course, everything is custom and unique and different. So it's the first time a lot of companies are doing it, are actually installing this type of equipment. So all of that is leading to a lot of change orders at the site. And I'm sure if you've been involved with this industry, change orders are not good in terms of trying to keep on budget and trying to keep on time. So that introduces a lot of cost overruns, a lot of delays in the schedule, and that's bad for all parties that are involved. So what's interesting about that is that a lot of these challenges, or many of these challenges, are the same exact ones that product manufacturers faced many, many years ago. If they want consistency in the products that they deliver, and you can be talking about the automotive industry, consumer products, if you're manufacturing it in lots of different locations, lots of different environments, you're going to have a lot of variability. So obviously many, many years ago, there was a push to get to a very stable, very consistent, very repeatable type of environment where you are making stuff or assembling stuff. And that has kind of been seen as a type of solution to this construction problem for processing plants. So the idea here is that you almost have something akin to a plant or a manufacturing facility where you have prefabricated components that you then ship off to the construction site. And from there you hook it up, you run everything you need to run between everything, electrical, piping, interconnect, whatnot, and this reduces the variability that you see at the construction site or the overall project, right? Because you're removing variability, you're improving repeatability, and you have fewer change orders overall. So this is modularity on the construction side, but really we're talking about prefabricated modules that you would then put onto a skid, you ship it, train or trailer, and then you then connect it all up at the construction site itself. So that is the construction side. Let's talk about the design side for a second. So we talked about increasing complexity, increasing size of projects. Now, traditionally, engineers have had a certain amount of work with these projects that are custom engineering work, right? So it's unique to every single project. And there's a certain amount of work that has been reused. You can always find some reuse almost in every project. So that has been acceptable. The issue is that as these projects increase, the corresponding amount of custom engineering work has increased, right? And that adds to more of this design work. And as it increases more and more, you get to the point where this is almost overwhelming. Not only do you have, it's too much work for one engineer, but as you add more engineers to the same project, they have to coordinate and collaborate more closely. That adds process complexity. So, and by the way, the gold color here is the custom engineering work. The blue that you see in the P and ID diagram behind the engineer is the reuse. So one of the motivations to move to a modular platform from a design perspective is to change that mix. Right? So the idea is instead to have a little bit of custom work, custom design work, and have a lot of reuse. Right? So moving to a modular platform lets you do that. It lets you reuse a lot of design work. So let's talk a little bit more about how that works. So in the middle, you have a modular platform, and you can combine different modules to create custom equipment. Right? So what we actually have here is we're increasing variability, yet we are also improving or increasing reuse along the way. So all of this relies on this concept of a modular platform. So to be able to do this, you have to have a platform. And that requires some changes. You have to have modules that you can swap in and out to have different capabilities, right? So you can imagine you have a core set of capabilities that you're going to implement as a design solution that fulfills different functions that are almost in every single project that you have. And then you have these modules that you attach to that core that fills out the unique capabilities of that project. Okay, so getting to the point where you have a platform is a critical step in this process. So how do you get to that point? Well, one of the first steps is you have to get alignment between functions and modules. Okay, so what you can see here, going from top to bottom in these different columns, are different modules that fulfill a specific function. Like there are 3 here you can see for filtration, 3 for purification, 3 for measurement, 3 for heating, 3 for distilling. But they might have different capacity, right? So they might be able to handle a certain flow rate through them. They might be able to remove a certain size particulate for specific modules. You might have different things that can be measured. You might have different heating capacity. You might have max temperatures. So this is the way, if you're able to swap out these different modules, then suddenly you can change the function of the plant by changing one module, right? So that is the key or critical capability here, the flexibility that a modular platform provides. And by the way, so this is not just related to the design work. This is actually closely related to requests for quotes. If you can cobble together 80% of the functions of a processing plant very quickly, and you can guesstimate the last 20%, well, you can respond much more quickly. And also, you're going to be able to respond with a lot of confidence. And when you can respond with confidence, you can tighten that window of uncertainty that drives whether or not you're going to bid conservatively or bid aggressively. So you can win more projects with more confidence at the same time. So that is the idea behind aligning your functions with your modules, and that is a key step. Can't be underestimated. Another key aspect of a modular or platform approach is managing interfaces. So this is the enabler for how you swap modules out for one another. They use the same interface, or they have a managed interface, right? So you know what the interface looks like, and you have modules comply to those interfaces. whether they have variability in them or not. So a lot of people look at interfaces and they think of mating interfaces, how different components can physically fit together, although there are a lot of, I would say, non-geometric aspects of these interfaces as well. They should comply with different professional standards from professional organizations. Here you can see SMA standard pressure vessel fittings standard. But also they should take into account piping. They should take into account electrical connections, and those both from a power and a signal perspective. You're going to have electronics involved with almost everything involved, almost every single module. So that's very, very important. So that might include, especially when you talk about signals, using an IEEE standard for communication between the modules. So that is also an aspect of the interface that must be managed. So let's talk about what you can use to enable it. As we talked about before, this isn't just one capability. You see mechanical design and ensuring that you have the capability to model everything physically from a mechanical perspective is really, really important. And being able to automate it is really important as well. So being able to use standard framing and sheet metal design is really critical here. From an electrical interconnect perspective, being able to develop the logic diagrams, schematics, the layouts, and then being able to route those cables and wires through your modules and making sure they can connect properly is really important. Then you get to P&ID. So this is another aspect of interconnect that's very important. So being able to lay out those diagrams, being able to route the piping through the modules, very, very important. And then also, when we talk about analysis, this isn't just important for the modules, and it is important for the modules. You need to be able to, if you want to isolate functions and align them to modules, you need to be able to verify that they actually perform that function repeatedly. So you can use analysis to do that digitally before you move on and do it physically with prototyping and testing. That is very important, but it is also very important to be able to validate that the entire system works together as well. So when you cobble together 3 or 4 or 5 different modules onto your core components, you need to be able to make sure that they do, in fact, work together as intended. So this is another way that analysis and simulation can come into play and add value. Managing interfaces is very important to define them, both from a mechanical, non-geometric perspective, interconnect perspective. All that's very, very important. Excuse me. And then also it's really important to manage all of this from a data perspective or a data definition perspective, right? So you're going to want to know what configuration you delivered on one project compared to another project. You're going to want to be able to manage the interface as its own entity, both the geometric and non-geometric stuff. You're going to want to be able to manage each of the modules and configuration manage those because they will change over time. Make no mistake. Your platform might expand, it might contract over time. You need to be able to explicitly manage that. So that runs the gamut of my presentation. We talked about the pressures that are driving a lot of construction companies and engineering companies to look at modularity. We talked about why it was important from a construction perspective. We talked about why it's important from a design perspective. We talked about 2 key enablers, aligning functions with modules. We talked about interface management. And then here we're looking at the ecosystem of capabilities that can enable it. So with that, I'm going to hand it over to Michael.
All right, thank you, Chad. So with all of the talk of modularity, we wanted to focus this next part on the software side of it and the solid edge modular plant design. Okay, and so where that really kind of stems into and gets more specific is, as you know, Siemens delivers the software foundation for the digital enterprise. We do this through the Siemens Digital Innovation Platform that we see here. Now, this is for large enterprise companies or small to medium-sized companies and even startups. The Siemens Digital Innovation Platform provides the solutions for our customers to meet their needs, their engineering, and their manufacturing challenges. And so a lot of these are going to be covered in areas like the mechanical and electrical design, but not forgetting the virtual prototyping with solid edge simulation, as well as data management. So we're going to be creating data. We need to probably manage these files and this workflow. Now, if we dig into this, we'll see that solid edge is an essential part of this Siemens strategy to ensure that companies of all size can benefit from this Siemens Digital Innovation Platform. Now, we're going to dive in and focus specifically on the solid edge portfolio today, with the design and simulation and manufacturing areas. And we also have excellent data management tools to manage all of the digital data and the processes that these areas are going to create and need to be managed. So with that, let's take a look at our solid edge portfolio. Now, the modular plant design that we've been speaking of, it falls in the realm of the mechanical design space in this whole pillar of the solid edge portfolio. And so with that, talking about solid edge modular plant design, what industries does this fit into? And there's really a multitude of different industries that fall into play. People automatically, a lot of times their first thought is oil and gas just when they think about pipes. But really, I tell people, if you design a product that has pipes connected to it or piping or tubing involved, then it's probably a great fit for your needs, as well as you might be the person that is going to be responsible for actually doing the plumbing, and that might be your specialty. And so we would easily fall into all of that. One thing that we sometimes don't think about is water treatment facilities. Every municipality in the world needs to have some way to deal with the water that's used and how to reuse that. We're talking about our reuse of engineering, also reuse of our natural resources. Industrial machining, and a lot of times getting into maybe even air conditioning equipment or refrigeration. Industrial food processing equipment, there's tons of piping and tubing involved in that, and not to forget about pharmaceuticals. Okay. And so, looking at all of these, this is where we want to kind of introduce the modular plant design has multiple modules involved, sticking to the whole term. And so we have the solid edge P&ID design, and we have the solid edge piping design for the 3D side. And these can be working on their own, or we have some interactive data exchange to where we can share data between the two environments to prevent recreating the wheel and entering data multiple times. So if we look at this whole process workflow, okay, we're going to start off by communicating our designs in our P&ID, and then we're going to, we're going to plan our designs with our P&ID. Then we're going to communicate how those designs work together and how they fit together to make sure that they will be able to fit in the envelope of space that you're allowed to be using, whether or not it be for shipping purposes, if it's going to be in a truck, on a skid, or in a container, shipped overseas, various different aspects. And then finally, we need to be able to manufacture it and create it. So we're going to look at the various tools within inside of Solid Edge, and one of those being a new tool called the Isometric output, so that we can create these fabrication piping drawings so that it can be more easily read by the shop. Now, P&ID, we've been saying that acronym a lot, and some of us might not know what that means. And so depending on your geographic location, for a lot of us it means process and instrumentation diagrams, and for some of it, it means piping and instrumentation diagrams. But we're really talking about the same thing. The 2D schematic that gives the details of how things connect together and really more of the workflow or the connectivity of modules or even individual designed components. All right. Now, this tool within inside of the Solid Edge portfolio can be all by itself running independently, or we can integrate it with Solid Edge 3D piping design to communicate that more into a virtual world to create your full digital twin. Some of the key aspects to there is we provide you with a extensive symbol library for the P&ID symbols that meet regional industry standards, as well as being able to create bills of materials from your P&ID, and also being able to communicate this information through a standard format like a PDF that doesn't require special software to be able to read or communicate your designs with other members of your team or even members of outside of your team. All right. So then the next brings us over into the Solid Edge piping design side of things, the 3D, to where we can see how things look at in real life. All right. And so some of the things about this is we're able to automate this piping design, either completely standalone, not related to a schematic, or it can be connected to that P&ID and reread that information in. This can be something that can be added on to those people that already have an existing Solid Edge license, and then when they want to expand the capabilities, or it could be for people that don't yet have Solid Edge and need to expand out into the present day of technology to be able to start creating these 3D digital twin environments. Okay. Now, getting into the workflow and the capabilities, again, being able to read data from the P&ID if necessary, automatically creating the 3D pipe routing, and then also your fabrication drawings, whether it be a Solid Edge draft with multiple orthographic projections, or a single line isometric drawing or diagram for fabrication. Now, so there's some other capabilities within inside of the Solid Edge piping design, and we do leverage a tool called Isogen to create these single line isometric drawings or pipe fabrication drawings. And it's a unique file format that many times is required by shops that you're using to actually fabricate these. And we can actually decide whether or not we would rather have these out as a more neutral file format like a DXF, or do we want to stay into our Solid Edge draft format and keep something more familiar to us. And expanding out these capabilities even further, it's not limited to just round pipes. We can also get into, we don't really care about the profile. So it could be a cable tray or HVAC ducting, and then being able to automatically generate your bills of materials complete with cut lists and things of that nature can be a huge time savings. And also, since we're just creating native Solid Edge parts and assemblies, we can still use our Solid Edge draft functionality. Now, we do provide you out of the box with an extensive library of industry standard symbols for P&ID and industry standard fittings for the 3D piping, pipe fitting library of parts, gaskets, elbows, T's, those types of things. And as well, as you see down here in the bottom, we can also create customer-specific libraries. So each customer can expand these out-of-the-box libraries and put in their own custom components and tailor it to meet their needs to save time, which saves money, of course. Now, back to kind of leveraging that whole solid edge portfolio and being able to run with inside of here, we still can take advantage of all of those other benefits that we get with solid edge, like being able to efficiently work with massive assemblies, okay? Taking advantage of the synchronous technology to where we don't care, where or what program a particular model might be created from, but we can rapidly make changes to it and make it our own, as well as express route for very quickly creating and automated the 3D routing assemblies, as well as solid edge frames. If we need to create these skids or crash skids, we want to be able to make sure that we're using the correct sizes and standard sides of structural steel and things of that nature. Also, still being able to very quickly pretty much automate the whole generation of 2D drawings per your international standard of your geographic location. And not to forget, in this whole digital twin environment, that we can do virtual prototypes so that we might not even have to do any physical prototypes or just one of them. So using solid edge simulation for the stress analysis to make sure it's not going to buckle or break. Getting into the computational fluid dynamics of flow EFD to make sure that we're going to have some smooth flow or make sure that we're getting our goals done. Jumping into that electrical side of things so that we can make sure that we have our whole environment replicated in a digital space, solid edge wiring design, and also making sure that we meet all of our specifications. We have solid edge requirements management. And then how are we going to manage all of this data? Well, we have from the PLM, the Product Lifecycle Management Capabilities Team Center, and also some more higher-end complex piping analysis for, FlowMaster for 1D piping analysis. And so with these modules, talking about modular plant design, the solid edge P&ID, again, can be standalone, but we can actually come out here and communicate that information, have standardized pipe specs for your company, tailored to the way that you guys build things with the components that you put into a pipeline, and share that information back and forth between the 3D environment to do the solid edge piping design, whether it be piping, tubing, HVAC, ducting, and generating all of this information in the virtual space to do all of your virtual testing as well. Okay, so let's jump over into the product itself, and let's just take a look at how the system actually works. So I got a kind of a simple little skid here, but a very typical kind of modular unit that we have here with a couple of tanks involved, a heat exchanger up here on the second tier, connected by 2 pumps down here in the bottom, and a strainer or a filter over here that's going to be involved with our whole process. And then even, I'm not going to get into electrical today, but you'll see a nice electrical cabinet over here, because pretty much everything that we design today has some form of electronics involved, whether it just be power requirements to the pumps or sensors and flow meters that need to be monitored, and temperature indicators. Now, also, so here we see the 3D environment. We have our modular plant design toolbar now up here that just expands the capabilities of solid edge. And then there's that second side of things where we have the 2D schematic. And so this is a project-based system to where I can have many different types of documents and many different sheets. I can have as many sheets inside of here that's required, because very often we run out of space on one page and need to continue on to another. And so that's part of the intelligence here, to where I can say that, hey, does this pick up on page 2 or page 22? So having these navigational tools to be able to make sure that you can track your pipelines through these more complex units that you're designing. Also, if you're not familiar with what a symbol is, you can hover your mouse over it, and it'll tell you that, oh, okay, this is a tube type heat exchanger, or this is a 2,000 liter vessel, this is a 5,000 liter vessel, what size the pipes might be, and various things of that nature. So, typically in a process engineering environment, I'm going to split my screens here so that we can see both environments here, but we might have a situation where we need to work connected. Okay, we don't have to, but if we do need to create both types of documents, this is a huge advantage, to where I don't have to recreate everything over inside of the 3D once I've laid it out in 2D. And so we can see that as we click through here, it will highlight in real time both environments, so that if you weren't the one that created the 2D, or you weren't the one that created the 3D, you can see how these worlds connect together and see the bigger picture. Okay. Also, we can see information from the PNID about what information about that particular component and what process that it's doing. So again, typically things are going to start in the PNID, the controlling document. So if we came over and we said, I wanted to add a pump in here that's going to connect to this heat exchanger, all right, we can very easily do that, whether or not we wanted to sort through our whole library of components. But one of the big advantages to working with a database is we're able to run quick and efficient queries to find things that we're looking for. So if we know we're looking for a specific manufacturer, we can look for that, or any kind of data about that component that we might have in our database about specifics. Or we could just say, hey, I'm looking for a pump. So maybe I'm looking for all of my pumps here. So I can just type in pump, and it comes up with the 3 different pumps that I have in my particular database right here. And so we can choose which one we want. And we find it would say, okay, I want to put that one in. And it goes and it grabs the correct symbol there for us, so that we don't even have to look for that. We can place it into our design. And then we can also see, I want to make sure I don't duplicate any tag numbers for this component. Okay, so we can have it generate tag numbers for us automatically that haven't been used, or we can come in here and say, hey, has P3000 been used before? And I asked that question, and it has not. So we can come in, and we can also add in more process-specific information. Okay, so this pump is going to be carrying hot water coming out of a heat exchanger. And so we can set up different default kind of selection lists and put in all of this process-specific information right into the PNID. From there, I just need to come in and say, hey, let's connect this with a pipeline. Okay, so what kind of a pipeline do we want it to be? Well, we can come in and draw the lines to connect them. Once we do that, these stay connected. Okay, so you don't have to redo the drawings after you move things around to make it fit. If it crosses over, it'll automatically break that for us. But we need to tell it, hey, what size pipe am I working with here? All right, and so we can type this in manually, but that's going to open us up for the possibility of errors. And so we can pull from our pipe specs. Our pipe specs are going to tell us, hey, what we're allowed to use per that specific pipe specification, and what wall thickness of material it's going to be, all of that good information. Again, we can come in here and apply process-specific information, okay, so that can be relayed or put onto a bill of materials. And we can also give it a tag number. Maybe I want this to be my PL300 for my pipeline 300. And we can apply all of this information and tell it what we want to be visible on the actual drawing itself. Okay. From here, we can actually get into some more advanced functionality, like I need to put a control valve in here so that I can turn on and off the flow either in or out of the heat exchanger. So for maintenance purposes or whatever reason I might need there. So instead of just going over and grabbing any old valve out of the component database, I can actually have our P&ID tell us, hey, what am I allowed to put into this size and specification of pipeline? Okay, and so it's going to search through there and it's going to say, okay, well, based on the pipeline that you're using, the pipe spec, you're allowed to put in these 4 different approved pieces of equipment for this size and specification of pipe. And so this globe valve will work perfectly for my needs here. And I can just go and drop it right in on that nozzle, and we can give it a tag number here as well. Okay. If you want a list to be provided of, if you have that part of your workflow is you have a predefined list of tag numbers that need to be used, we can do that as well. But I'll come in here and say that this is going to be my V3000. And again, if you want, you can put in more process-specific information, but it's not required. It's just some extra information there that can be valuable in a bill of materials or for any other purposes. Now, we can also get into more specific information about, hey, we don't design these valves, we buy them from somebody. So hey, let's pull up the manufacturer spec sheet here of the who makes this pump, or this valve. And so now we have this right at the engineer's fingertips. Okay, so these are all some great tools, just being able to streamline and put all of this information at the user's fingertips so that they don't have to go and look for them. So my information here, I got it all together, and maybe I want to share this with somebody else, okay, because all of my bills of materials, these are all automatically generated for us. Depending on what information we want to be visible on here, we can update all of this. Now with this, if I need to communicate this information with somebody else that doesn't have access to this program, we can actually say, let's create a shareable document like a PDF. Okay, who doesn't have a PDF reader these days, right? So we can come in here and we can just generate this, and we can actually create a complete package of all of the drawing sheets that are inside of here. And now we have this all together in a very easily shareable and emailable piece of information that has all of the intelligence built inside of here. Okay, complete with, the pipe information, the component information, the navigational tools to be able to hyperlink through to different pages, and even the bills of materials and component sheets that we have inside of here as well. Okay, and being able to navigate easily from pages. So this is a great tool to be able to collaborate with different either departments within inside of your company or people outside of your firm as well. Now, getting all this information over and getting this into the 3D side of things. Okay, how do we get this all connected together? We just come back over here into Solid Edge, and we say, hey, I want to refresh this information. And this could also be a workflow that maybe have gone through, your data management tool like Team Center, and then the notification has popped out from the 2D guy to the 3D guy, person, and then said, hey, we need to make sure that you've got these new changes that I added, or that the process engineer added to the P&ID. And we need to make sure that that gets incorporated into our 3D design so that we can make sure that things still fit properly, we don't have any clashes, and things of that nature. So it's going to do a system of checks to compare what's in the 3D Solid Edge assembly to what's in the 2D P&ID. All right, and then it's going to color code this to-do list. And this is basically a shopping list here that we create, so you don't forget to put anything in here. And so we can start off with our orange components here. These are things that don't exist yet. And we can just say that I want to place this into my CAD environment here in Solid Edge. So this is going to pop up and open my Solid Edge standard parts, which has now been expanded greatly to extend what's available there from a piping perspective. Okay, and I can choose what I specifically want to use. Okay, now in a minute I'll show you a more advanced way to do this. But if we get back over into here, we can come in and we can place these components right into our assembly. Okay, and we can just come down here and activate this little platform here, and we can line up our alignment tools here, and we can say that we want to get this placed into our solid edge assembly, just using standard solid edge assembly tools. Okay, and so that gets checked off there, and now we can move on to maybe the pipeline. Okay, because we need to get that pipeline in there first, and that's why there's a blue dot on this little component there. That needs to be put in first. That's a piece of main equipment. Now, if we notice over here, all of my pipelines that I've got already created are in their own subassembly. Okay, so Solid Edge Modular Plant Design is going to assist us with that process to where we can create the subassembly right here within inside of our Solid Edge environment. And it's also going to name this subassembly to match the tag number from our P&ID side of things. So it's keeping all of this data integrated and up to date, so that we're ready to maintain that that data exchange. All right, and then once we get this here, we can just in place activate this and create our route. Okay. And so we can have the piping tell us, based on the information from P&ID, what nozzles are supposed to be used in this this pipeline. And so now we know exactly what pump nozzle to go to, and we can hide all of that now that we know where we're going. And now we can leverage the tools within inside of Modular Plant Design, like ExpressRoute. All right. And then we can have this help us in a very easy fashion to draw the path from my heat exchanger nozzle here down to my pump. Okay. And then it's going to give us a few different options here based on the geometry that we have. It's going to create some line of best fits here, and we can choose which one meets our needs best. If we need full control, of course, we can still use ExpressRoute to draw individual lines to avoid existing pieces of equipment. Okay, if we needed to get more involved with that. But from here, we can take and we can say, let's turn that path in, or turn that express route into a piping path. And now if we weren't connected to P&ID, we could tell it exactly what type of pipe it needs to be and have it create that. But we already did that in our case. We're working connected, and so we can come over here and we can assign a pipeline information from P&ID to this path inside of Solid Edge. Okay, so it renames that path to match the tag number again from P&ID, and then it's going to automatically build that piping assembly for us. Okay, and so now that it knows all the information, it's going to say, okay, I'm looking at the pipe spec in the background, and it tells me what types of elbows do I need to be using. Is it going to be a short radius or a 5D radius elbow? Is this a Schedule 10 or a Schedule 40 or a Schedule 80 pipe? Is it stainless or is it carbon steel or is it copper or is it PVC? Do I want to use flange connections, or is it threaded, or is it butt welded all together? How is this supposed to be built? And so all of this is automatically coming from the pipe spec, and these are customizable. You can build your own pipe specs. You can modify the ones that we provide you. But in this case, we even said that we wanted welding gaps to be added, and it knew to use a welding neck flange as opposed to a slip-on flange, and it even placed a gasket in there for me. Okay, so it's really automated this whole process for me. I can finish this off if I want to put that valve right on this nozzle up here. I can get that flange out of the way, and whenever I placed the valve into the P&ID, I used the pipe spec. And so now I have a more automated way to put the 3D models in there if I leverage the capabilities of the power of pipe specifications. And so we can actually have all of our capture fit information already added in here. Again, just base solid edge functionality of building my assemblies. So I get it placed into here. Life is good. And then I can come in and I can tell it, all right, let's update all of the pipes and make sure that there's no finished connecting information that might be missing here. So we can recalculate this pipeline. Okay. And then we can decide whether or not we want to use solid edge drafts to create your standard orthogonal connection or orthogonal projections of the pipelines, or do we want to use more advanced isometric drawings to create more of a pipe spool drawing? And if we needed that, we can come up and we have the isometric tool right within the plant design library here, and that's going to batch generate here this drawing here for us. And in my case, I told it that I wanted to use the solid edge draft. Okay, and so I can run this from a top level, and it can come out here and actually batch generate a bunch of different pipe spools in one operation. Okay, or I can generate them individual by individual, and here we can have our drawing automatically generated with the elevation callouts, the northings and eastings on each one of the connections, the information about this. Now I know that I need exactly 3-point line linear meters of 100 millimeter pipe. It also knows that I need studs automatically added in here, even though I didn't add it to the 3D assembly. Okay, so it has that intelligent information there in each cut length of piece of pipe and the end preparations based on the type of connections here. And so that's a couple of different ways that we can do things here. And so if we come back and look at some of our customers, we average a 30 to 50% time savings. These guys here, 1,000-year-old brewery company, they were experiencing it 3 times because of the many different pieces of software that they were using, as well as maybe another company here that makes compressors, but they also do large systems that has a lot of intricate piping and tubing involved.
Thanks again to our presenters today, Mr. Chad Jackson and Mr. Michael Mooney, and thank you all for joining. With that, the session is closed. Goodbye.